and we'll get going on today's stuff. So how did y'all feel about that? Okay. So if that was like a complete disaster for you, you just want to make sure you're practicing more and going back, doing the homework over until you're comfortable. And if you're at a point where you've done all the homework and you just feel like you need more examples, come talk to me or the tutoring lab across the hall. They have plenty of resources there where they could give you more sample problems to work with. All right. So today we are going to continue what we were doing last time, and that was percentages, proportions and percentages. And we're going to start today with applications of percents. So were there any questions on homework? Yes? What do you got?
Just the one.
Can you tell me the page? And
It's going to be number 25 on page 24.
Page 24. You got to. I said go ahead and work ahead if you want and see how it goes. So why don't? Yeah, what? That's fine. That one. Let me just look at it.
I can ask you after class.
Yeah, let's work through today and see if that helps with that problem. Okay. All right. So we are going to look at applications of percentages. So this is stuff that has to do with money. I think most of these problems are dealing with money. So, when you go buy something, obviously you always have to take into account that you're going to have to pay tax, right? So how do they come up with your total amount? Well, your total amount is going to be equal to the price, right? Whatever's like on the sticker. And then you have to add to that the price times the tax rate. And the tax rate is usually given to you as a percentage that you have to convert to a decimal. So that's kind of a formula. Another way we could write this is, total T equals price plus price times rate, R, P times R. That's another way you could write this formula using just letters instead of words. Does that make sense? Yes? Yes. Okay, now check this out. There's another way that you can use this formula that in some books they use a different formula. They actually write that the total is equal to the price times 1 plus R. Now, I'm saying that that's the same formula. What did they do? Like, how is this the same formula as this? That's right. On the right-hand side, they realized that both of these have P in it, right? So they factored a P out, and it left a 1 plus R, right? If you multiply this P back through, you get this, right? So this is an alternate formula that you can use. It's a little easier to compute because all you have to do is take 1 plus the rate and then multiply times the price. So I don't care which one you use, but just be aware that these are both there for you. And then the other formula we're going to use here is coming up with the percent increase or decrease of something. And this could be anything, like, if you have something that goes on sale, right? You're interested in buying a TV at Best Buy or something, and it goes on sale, and you want to know how much they decrease the price by as a percentage. What you do is you take the new price, you subtract the old price, and you divide it by the old price, and that gives you your percent of increase or decrease. And the way we'll be able to tell if it's an increase or decrease is whether or not this number is negative or positive. So positive would be an increase and negative would be a decrease. We'll just have to work through some examples for you to see what I'm talking about. All right, so let's look at that first one. Amy bought a pool hall. I'm not sure why Amy would want to buy a pool hall, but that is what she did. Okay, so Amy bought a pool hall for $219,765. This price includes a 5% state tax. What was the price of the pool hall before tax? So this was the out-the-door price that she paid, but it includes tax. Do y'all understand that? So what the question's asking is how much was the pool hall, what was the price before tax? So we are going to use one of these formulas. It's our choice. What do we actually know? What is given to us in this word problem?
Total.
The total, right? We know the total. We know that T is equal to 219,765. What else do we know? The tax rate. And what is that tax rate? 5%. And if we're going to use that rate in the formula, it must be converted to a decimal. Please do not forget that, all right? Because that will throw all your numbers off. So we actually want to convert this to a decimal. What is 5% written as a decimal? 0.05. And what is it that we're actually trying to find? The original purchase price, right? Which would be P. So P is what we want to know. So what I'm doing here is kind of making a list of what I know and what I don't know. And then all I have to do is go over to the formula and just kind of plug everything in and then try and solve for the one thing I don't know. So would you like to use the top formula or the bottom formula? I don't care. You want to use the bottom? Okay, let's go with the bottom one. So I'm going to rewrite this formula right here. And I'm just going to replace T with 219,765. That's dollars, right? Equals, now price, you don't know, right? So I'm going to put P. And then 1 plus the rate, which is 0.05. Do you see how this would make a huge difference if you put 5 here instead of 0.05? Okay. Now we're going to try and solve for P. So to get P by itself, what are we going to need to do? Do what's in here? And we can put these together, can't we? If we add those, let's go ahead and do that on the next line. 219,765 equals P. Let's go ahead and add those together, so it's 1.05. And finally, to get P by itself, yeah, we're going to divide because this is multiplication right there, right? So the way we undo the multiplication is we come through and we divide both sides by the 1.05. So I'm going to divide this by 1.05. And then I get my calculator out, or you get your calculator out. Anybody having trouble getting calculators? No? Maybe we'll have a calculator quiz soon, where I just go around and see if you have a calculator or not. All right, so you take that 219,765 and divide it by 1.05, and we get 209,300 is the price, and this is dollars, right? So that was the price that the whoever sold the pool hall. That's the price they had listed. Amy bought it. She paid the state tax, and wound up having to pay 219,765. All right, questions? All right, let's move to the next one. Steve is going to do something here. Let's see. Oops. Steve needs to buy his sister a birthday gift from the mall. He sees a shirt that is normally priced at $24.50, but is on sale for 20% off. If the sales tax is 8.25%, how much will Steve pay for the shirt? All right, let's think about this. $24.50. Is that the price of the shirt? Is that how much he's going to pay for the shirt before tax? Is it? No. Because it's on sale, right? And how much is it on sale for? 20% off, right? So we need to figure that out first. We need to figure out how much this shirt is actually on sale for, right? So how can we do that? How can we figure out what 20% off would be? Yes?
Just divide 2450 by 5, right? And then you would get the 20%.
Why divide it by 5?
Well, because there's 5, 20, and 100.
Okay, you could do that, yes, but what if this was 13%? Wouldn't be so easy, right? So I agree with you. With 20%, you could do that, but with a different percentage, that method wouldn't work. So I don't want to go with that method. Yes?
You can multiply 2450 times 0.20. And
Okay.
whatever it gives you, you just subtract it from 2450. And that's it.
Okay, so look, I mean, have we all done this before? Like gone to buy something and something's 20% off and you try and figure out how much it's going to be? So one method is to do exactly that. You multiply times 20%, which is 0.2. Figure out how much that is, and then subtract that.
2450.
Do you all agree?
Yes.
You sure? Okay, I agree with that completely, but it's not the best, fastest way to do it.
What if you subtracted the 8.25 from 20%, which would be 11.75, and then you would multiply 0.1175 times 2450?
That's a good question. I wonder if that would work. Let's leave that as an open question, okay? Because I know what you're trying to do, but let's see if we get the same answer, all right? So let's go back to the 20%. I think most of us figure out like what's 20% of what I'm going to pay and then subtract that from the original. Yes?
Yes.
That logic, there's nothing wrong with it. There's a better logic. Instead of looking at it as how much is the 20% off and then take it away from the price, how about just asking the question, what's 80% of that price? Right? I mean, if 20% is off, then aren't you really just going to pay 80% of that price? So instead of taking 20% and subtracting it, here's what I'm going to do. The price of this shirt that I'm going to pay, right, is going to be the price, $24.50, times, I'm going to put parentheses for times, 0.8. See, that's 80%. Or 20% off if you want to look at it that way. So this does both the 20% taking it away all at one time. So do y'all see how that's a little more efficient to do it that way? Okay. Now go ahead and someone give me what this is. 19.68? 60. Okay. So that shirt on sale, right? Its sale price is $19.60. And you can check this yourself. If you did 0.2 times that and subtracted it, you get the same number. All right? So that's how much the shirt is going to cost, but then I have to pay tax, right? So the total is going to be the price times 1 plus the tax rate, which is going to be $19.60. I'm using that formula now. And then 1 plus the tax rate and our sales tax here in, I don't know, is that the right sales tax rate? I think it is. So I need to convert 8.25% to a decimal, so 0.0825. So I just move that decimal point 2 places to the left. So my total is going to be this computation. I can just use my calculator for that. I can do what's in parentheses first. Who has that? 21.217? Okay, so I don't know, probably round at the store, who cares? I mean, we can just leave it as, you could leave it as 21 or 22, I wouldn't care. All right, close enough. All right? So we are going to be out the door 21.22. Now, sir, what was your name? Julian? Okay, so Julian suggested we try something different. Have you tried it?
No,
You didn't try that? What Julian suggested is why don't we take, and Claire, help me make sure I do this the way you wanted me to. Take this number, and then you're going to do something with the percentages. You said subtract these?
yes.
So if I take 20% off, and then this, then that would be 11.75%. So let me just write that down. 11.75%. And what do you want me to do with that?
Multiply by $24.50, and that should be your total.
So is it? So if I take this and you want me to multiply this percentage times this?
Yeah, or we'll take the point.
Okay, so take 24.50 and multiply it times 0.1175. I'm just doing what you're suggesting I do. So that's what you want me to do? I don't think this is going to get it. It's going to be like 2 something?
2.87.
2.87? Okay, now if I subtract that from that, do I get this? Because this obviously the shirt's not $2.87, right? But maybe that's how much is off. So what happens if you take $24.50 and... Yeah, so it's not quite. The problem is that the tax rate is only on the sale price. By subtracting these two right away, you're not taking 8% off of... See, this 8%, 8.25% is not on that number. It's on the reduced amount. So this won't quite work. Does that make sense?
Yeah.
Okay. All right, questions on that? Sure? Okay, this actually happened to me, I think it was a couple of years ago. I'm going to kind of make up my own problem here. I was at Lowe's buying a barbecue grill, okay? And I don't remember how much the grill was. It's pretty expensive though. I think it was like a $600, $700 grill, okay? All right? That's because I've owned a lot of cheap grills, and so I finally got a grill that was going to last me. What's that? Yeah, I know. It's because I wound up buying 10 cheap grills instead of one, yeah. So I actually said, I'm going to invest in a decent grill. So I got myself a $600 grill. But I had some coupons and the ability to do reduce that price. I had the ability to do 10% off, okay, for a military thing, which has to do with my wife. And then I also had a 10% off coupon, all right? And then my dad happened to have a 20% off coupon sitting around that I could have. He told me I could use it. So the question is, does it matter?
Depends.
Does it matter which I use? Okay, well, it would also depend on how they do it, right? How Lowe's would do it. So the way Lowe's does it is that if you do two 10%, then they'll do 10% off, and then they'll get that price, and then they'll do 10% off of that. Okay? This means 20% off, like the original price, right? Do you get the same result? Let's see. Let's check it. So let's do this scenario. First thing that would happen is what? I would take 10% off of this. So how could I calculate that?
700 times 90.
I would take this number and multiply it times 0.9. Okay, so I'm using the same technique we just used. Instead of saying 10% off, I'm saying 90% of this price. So I'm going to do 600, and I'm going to multiply it times 0.9, and that would be that first 10% off. What is that number? 540. All right, oops, 540. And then I would do my next coupon off of that, right? So now I'm going to take 540 and multiply that times 0.9 again because I'm taking 10% off. And what is that number? 486? Okay. So that's how much the grill would be. Now, this is one coupon. So what I would do is I'd take 600 and I would multiply times what? 0.8, 20% off. And what is that number? 480. Right? So now, $6, who cares? But I'm just saying, it's not the same thing, okay? Having two 10% coupons is not the same as having one 20% coupon. So, if you're going to buy, your carpet at Lowe's, right? And you add a 0 to that. Now this is going to add a 0 here, and then that's going to add a 0 here. And now we calculate. And the answer is no. I thought you were calculating it. Okay, so you save yourself $60, right? You save yourself $60 that way. So that's a little bit better, right? I mean, that might matter. $60, you can take your family out to dinner, whatever, right? So these are the little things that you want to pay attention to. And that's just off top. It's on topic, right? That's on topic? All right. All right. All right, so let's move to the next one. Thomas is selling his Honda CR-V on consignment by leaving it with the dealer, who will get 25% of the selling price. Ooh, that's not good. Y'all know what consignment is? You're basically paying somebody to sell your stuff. So you go give it to the dealership, they sell it, they take a cut, you get a cut. But you don't have to hassle with selling it. There's a lot of consignment stores for clothing and like furniture and things like that. They'll sell your clothes, they'll take a cut, but they have a store for it. You know, you don't have to handle that part. All right, so what must the selling price be in order for Thomas's share to be $1,475? So, now I don't see any sales tax in here, do you? Right? There's no sales tax in here, so we're not going to be using this formula because there's no sales tax. But maybe we can still resolve this. Let's think about it this way. I'm going to draw a picture. Let's just say this is the money that we're going to get from the sale of the car, right? That's the money that's going to come in from selling the car. And of that money, how much of it is going to the dealership? So we cut it up like this, 25% of this is going to the dealer, person who sells it. And then that leaves 75% of it to go to Thomas, right? So the question is, what does this selling price have to be in order for this piece right here to be what? $14.75. Does that kind of make sense in a picture? You sure? So whatever this selling price is, I take 25% of it, and that's what the dealer gets. Whatever this price is, 75% of it must be this number. So how can I write that out in a mathematical equation? Why don't we assign a variable to this? Because this is the price, right, that we're going to sell it for. Why don't we call that P? So what do we know about P? Is P this number?
No.
Okay. Is half of P this number? No. 75% of P is that number, right? That's what we need? So how could you write that down? 75% of P is equal to this. So 0.75, right? 75% of P, of his multiplication, needs to be equal to 1475. Let me write that down. 75% of the price must be $1,475. That's what Thomas needs. That 75% of the price it's sold for must be able to give him the $14.75. Converting that to an equation, 75% of multiplication price P must be equal, right? Now how do you solve that? Divide both sides by 0.75. So how much does that CRV need to be sold for?
$1,966.
What is it, 1,000?
$1,966.66.
Ooh, that's a lot of sixes.
Or 67.
Okay, that's all right. We'll just leave it like that. Yeah? I'm trusting that computation. Do we have anyone else that agrees with this number? Because I'm getting some looks out there like, okay. So if we sell the car for $1,966.66, then when Thomas gets his cut of 75%, he should make the $14.75 that he needs. We good? Okay. So my mother-in-law passed away a few weeks ago, and this past weekend we had a big like celebration of life type thing, and we've had guests in from out of town staying in our home for the past 3 weeks. And you know how that is? So we've had a house full of people, and today the last of them are leaving. I'm very excited to go home. But the reason I'm telling you this is because when you have like 3 families in one house, you create a lot of trash, right? So I had a lot of trash out last night, and something got into it. So I woke up this morning to my neighbor texting me saying that your trash is blown all over the neighborhood. So I walked outside, and sure enough, it was like 10 houses down. Because it's pretty windy last night, pretty windy today. So I spent the morning revisiting all the trash, and horrible, horrible, horrible. But I'm excited to go home today. All right, here we go. Javier, 2004, bought a television for $2,500. That's a nice TV, I guess. In 2012, he purchased a similar model for $950. What was the percent decrease from 2004 to 2012? Round to the nearest 0.1%. So we want a percent decrease, right? Percent decrease, that's what it's asking for. Now, we had a formula for that, and the formula that we had was the new minus old over old. You always do new minus old over old. So we want to take the new price, subtract the old price, divide by the old price. So what's the new price? $950. We want to subtract from that the old price, which was $2,500. We want to divide that by the old price, which was $2,500. And we want to do what's up on top first. Go ahead and subtract that out, and then divide by 2,500. I get negative 0.62. Now, I'm not going to ask you to raise your hand here. You can if you want. But maybe you got 949? No? Hopefully you didn't. Be careful when you type this into your calculator. If you try and type it all in at one time, 950 minus 2,500 divided by 2,500, if you type that all in at one time, you're going to get this number. And it's wrong because your calculator is actually going to look at that. If you type it in like that, your calculator is going to do division before it does subtraction. So it's going to divide these two first, and that's just 1. So it's going to go 950 minus 1, and you're going to get 949. So if you want to type it all into your calculator at one time, you have to put this in parentheses. So just be careful. Okay, so negative 0.62. What does this mean? Yep. 62%, we convert that decimal to a percentage, and then because it's negative, it's a decrease. That's why I don't buy the newest TVs, right? Buy like the TVs that are like a year old, and you pay a lot less, and in 2 years there'll be a better TV out there anyway. So, right? After about 4K, right? I mean, even like 1080p. I don't know if you even know what I'm talking about. If you don't, who cares? But, right, like 4K, like there comes a point where your eye can't even, like, you can't tell. And there's not a lot of programs out there that are in 4K unless you're doing video games and stuff. But okay. So, all right, what's next? Have another one of these? Gas. Oh, yeah. So check this out. I told you this document was written a few years ago, right? Back then, these were probably the prices of gas right now. That's why when I see people like, oh my gosh, it's $2.59 for gas, I'm like, yes. As long as it's under $3, you should be happy. All right, so look, price of gas increased from $3.25 to $4.05. What is a percent change to the nearest percent? So same method. You just have to figure out, what's new and what's old. So which is the new price? 405. And the old price? 325. And that's just from the words. It went from this price, so this is the old price, to this price. So we're going to go 405 minus 325 over 325. And you have? Or you can tell me. What do you got? 0.25? Which really translates to what? 25% increase because it's positive. A 25% increase in price. All right. We good? All right, we have to go through those. Why is this not going? Do you want to do something fun?
Yeah.
Yeah, it's mathematical. Okay, so let's do something fun. If I can find this. Hold on, let me see here. Oh yeah. I haven't done this in a long time. So let's see if it still works. No, that's not it.
Is it a game?
Yeah, kind of. Let's see if this is it. Yeah, here we go. Okay, you ready?
Yeah.
Okay, so we're going to do some math here. What you're going to do is you're going to choose any two-digit number and write it down. All right? So go ahead and pick a two-digit number. I'll do my own here. Okay? Now, I'm following the instructions here. Add together both digits and then subtract it from the original number. So for me, I'm going to add those two numbers together. So 3 plus 7 for me would be 10, right? And I'm going to take 10 and I'm going to subtract it from this. Make sense? And then I'm going to get that number, 27 for me. So you should have your own number. Does everybody have their own number? Understand what I did? Questions? Question? Come on, ask a question. What's up? What's your number?
58.
What's your number?
50.
That's the number you started with?
Yeah.
58? Okay, add these two numbers together. What do you get? 13, right? Subtract that. So you should get 5 and 4. So you have 45. Yes? Everyone got theirs? Okay, now on this list of numbers, I believe there's 100 numbers over here. 99 numbers? Well, no, there's 100 because there's 0 counts. So there's 100 numbers here. And you go find your number, okay? Find your number and then look for the symbol next to it. So like if your number is 91, look at that symbol. Everyone got their symbol? You sure? Okay, here we go. I'm going to click on this mystical ball. Was that your symbol? Yes? Should we do it again? Okay, I'm going to pick a different two-digit number. Okay, you ready? So let's see. I'm going to pick a different number. I'm going to go with 12. I'm going to add my two digits together, which gives me 1 and 2 is 3, and I'm subtract, and I get 9. Everybody ready? You have your symbol yet or no? I'll give you a second. We good?
Yeah.
Okay, let me see. Where's my symbol? Okay, I got it. Here we go. Now focus. Focus. It needs to read your mind, so clear your mind. That it? Okay. So if you just wanted you to know that the internet could read your mind. That's all I wanted you to know. What the heck's going on here? What the heck is going on here? My sister emailed me about this a while ago. A couple of years ago, she emailed me about that. She's all freaking out. What the heck's going on here? Right? So there's something's got to be going on, right? So let's just say the first time we did this, you had a number, right? Okay, let's just go around and see what the numbers were. What was your number the first time?
9.
9? Who else had 9? Okay. What was your number?
97.
97. Anybody else have 97? Was it right for you? Did it read your mind? Yeah? What did you have? 42. Anyone else have 42? No? These numbers don't sound right. Not your original number. Sorry, not your original number. After you did the little mathy thing they wanted you to do. 81. Who else had 81? Okay, what did you have? 36. Who else had 36? Okay. Anyone have something other than those numbers?
I had 27.
27, 72, 63. Y'all recognize anything about those numbers? 81, 36, 72, 63. They're all multiples of 9, aren't they? They're all multiples of 9, aren't they? I did it twice. First time I did it, I forget what my number was. 27? I don't remember. I think so. And the second time I did, I got 9. So every time I've done it, and it seems like every time you've done it, you've got a multiple of 9, right? So I'm going to go back to that website, and we're going to try it again. We're not actually going to do it again, but I want you to look at this table of symbols. I want you to look at 9s. See 9? See that symbol? Look at 18. Same symbol. 27? Same symbol. 36? Same symbol, right? So this table, this thing knows that no matter how you do your little numbers and subtract, that you're going to get a multiple of 9. So all they do is make all the multiples of 9 have the same symbol. It looks like it's reading your mind, but it's not, right? Obviously, we should feel good about that. It's not reading your mind. But I think the more profound question is why are we getting multiples of 9? Why are you getting multiples of 9 every time you do that? So do you want to see that or not?
Yeah.
Do I hear no? Yes? Okay, so let me just let's do something here. I'm gonna write. Someone give me the original number that they picked. 74? Okay. What does 74 really mean? This means you're going to take, like, if we go back to like what 74 actually means in when we're learning about numbers, it means 7 tens, right? Plus 4 ones, right? That's what it means. Or you could write that 7 times 10 plus 4 times 1. Agreed? Now, what I'm supposed to do next is I'm supposed to take the 7 and the 4 and add them up together, right? What's 7 plus 4?
11.
Okay, it's going to be 11, right? Okay, so if I take this 7 plus 4, I'm supposed to subtract it from that, right? So watch, I'm going to take this, subtract from that 7 plus 4. Yes? All right, now I realize that you could do this math and you're going to get your number. But what I want you to do is something a little more profound. I'm going to rewrite this as 70 minus 4 minus 7 plus 4. So all I did was distributed the negative through. You see that? I multiplied 70 times 10? Yes? Okay. The 4's cancel, don't they? Yes? Oh, yeah. Wait a minute. Hold on. Plus. Oh, they were supposed to cancel. This was supposed to be plus. Thank you. Whoever caught that. That was plus. This was minus. I switched that. I don't know why. They still cancel, though, right? And I understand that this is going to be, what, 63? But, just hang with me here. Isn't this 7 times 10 minus 1. What I did was factor to 7 out of these. What's 10 minus 1? 9. So this is going to be 7 times 9. Agreed? So that means that it's a multiple of 9 because it's 7 times 9. Now, I've not tried to convince you of this yet. I'm just trying to show you a pattern of something. Now I'm going to try and convince you. So let's say that I take 2 digits, call them x, y. So these are my 2 digits, like 37 or 42, right? What does that mean in mathematics? That means you have x tens and y ones, right? Which means you have how many tens? Well, in this case, I have 10 x's, and how many ones do I have?
4.
No, I have y ones, right? Yes? Now, what am I going to subtract from that? These two added together, right? So I'm going to subtract x plus y, right? Now it's algebraic. It's completely algebraic. So now let's go through this algebra. If I drop the parentheses, 10x plus y, I subtract x, I subtract y, and what happens to the y's? They cancel out. And what are you left with? 9x's, which is a multiple of 9. Because x is a digit, right? So if you go back and look at every number you picked, if you just took that first number and multiplied it by 9, that's what you got when you did all that subtraction stuff. So like when I pick 23 is my number, when I do my math here, I'm going to get 18. It's going to be 2 times 9. So I add them together, I get 5. I subtract, I get 18. So this proves that if you take a 2-digit number, right, take the 2-digit number and subtract the sum of the digits, that you are always going to get a multiple of 9, which is why it works. All right, now that was random information, all right? All right, let's get on to, I think we're supposed to be, for some reason this thing does not want to move. 22. 18, 19, 20. There it is. Let's take a look at these mixed practice problems. Mixed practice means that this is a mixture of problems that we've been doing, not just this section. So let's see if we can handle these. I think this is part of the problem that you run into on a test, is that if you get a word problem, it's not going to tell you, like, oh yeah, this is a percent problem. Use that formula, you know, t equals p times 1 plus r. It's not going to tell you that, so you have to be able to recognize it. All right, let's look at number 1. Assume that there are come on, man. There we go. Assume, come on. All right. Assume that there are 425 statistics students at NBC, of which 35 plan to go to nursing school. Of all the students who plan to go to nursing school are enrolled in statistics this semester, what percentage of the 15,435 students at NBC plan to attend nursing school? What? I'll let you read that again. So how would you approach this? Kind of a rhetorical question. Find 35% of what? Of the 425 statistics students. So let's draw some pictures, and then we'll see if that's going to work. Let's say that this is all of the NVC students, all right? That's everyone, right? That's all of Northwest Vista College. And how many are there? 15,435. Okay, so we got 15,435 students that go to Northwest Vista College. It says there are 425 statistics students at NVC. So that means of this, there's a small group here. These are your stat students, right? Statistics. And there's 425 of them. Yes? If all of the students who plan to attend nursing school, so okay, there's students that are come from Northwest Vista College that want to go to nursing school, right? If all of them are enrolled in statistics, that means everyone going to nursing school is from this group. That means this group right here is everyone that's going over here, right? What percentage of the total student body plans to attend nursing school? So go ahead. What were you saying? Oh, wait, hold on. Soon for which 35% plan to attend nursing school. I think I missed that, didn't I?
Yes.
Oh, 35%. So stats, if all the students who plan to attend nursing school are enrolled, okay, that just makes sure they're not in a smaller group. So I drew this arrow wrong, didn't I? Oopsie. I'm still getting my mind read over here by the computer. I'm freaking out. I missed my 35%. These are your stat students. It's a smaller group that's going to nursing school, the 35%. So of that group, 35% are going to nursing school. Okay. Now, you suggested we do what? Yeah, we first need to figure out how many people are in this little blue group right here, which is 35% of the 425. So we will do that. We need 35% of the 425, which is the same as doing 0.35 times 425. And someone I'm sure has already done that.
148.75.
What is it?
148.75 or
148. Let's just go with 148 since they're people. So we won't cut them up into smaller pieces. You can do the decimals or just leave it as a whole number. Okay? So we'll say approximately equal to. I'll put a little squiggly equal sign. That's actually a mathematical symbol. I'm not just like making that up for fun. Like that means approximately. So about 148 students are in this blue group. And it's saying what percentage of the total MVC body is that, right? So that's saying 148, right? 148 students is what percent of NVC student body? Yeah, my stomach's growling up here. And the way I wrote that down, hopefully that makes sense to you, where I came up with that question or that sentence from. Now I'm going to convert that to an equation. So how would I write that as an equation? 148 is equals, right? What percent? Well, that's what I'm looking for, right? So why don't we just call that x, okay? All right? What percent of multiplication, student body, how much? 15, 435. And now, to solve for x, you would divide 15,435, 15,435, and you should get a decimal there. So I'm taking 148, dividing by 15,435, equals x. What do you get? 0.96? wait, 0.0096? Is that what it is? Okay. All I heard was 0.96, so I was like, wait, that's like 96%. That's too much. 0.0096, but if you convert it to a percentage, what is that as a percent? 0.96%. So not even 1%. 0.96% of the student body at Northwest Vista College intend on attending nursing school. Let's skip number two. Let's go to number 3, and this will be the last one for, I think the last one for this section. I'm going to let you all work the others out. Students usually have trouble with this problem, and rightfully so, because there is some things we have to assume here. But this is actually how things like this are done. So it's a good problem. To estimate, okay, approximate, means this is not an exact answer, but it's an estimate. To estimate the number of trout, that's a type of fish, in Big Bear Lake, a sample of 40 trout were captured and tagged. After releasing them, a net captured 300 trout, of which 9 were tagged. What would be a good estimate for the number of trout in Big Bear Lake? Okay, so I'm a big fan of pictures, all right? So here's a lake. That's the surface of the water. Here's the lake. And here are all the little fish, right? Please do not. My classes are always very intimidated by how good my artwork is. They're like, he must have, taken years and years of art classes, probably still very active. That's a lake with fish, right? So if you can't draw that, don't worry about it. So here's your fish. And so what they do is they go in and they catch some, right? So let's say they catch these 3 and they tag them, right? So they've tagged them. Then they let them go again, right? So now, let me put a bunch of other fish in here, okay? Here are all the other fish, all right? So you got all these other fish in here. So now, they come back later, and you got all these fish in here, right? And you've got the 3 that were tagged kind of floating around in there, right? Yes? And they catch a bunch of them in a net. So they catch all these guys. And now they realize that, let's say, 2 of the 1, 2, 3, 4, 5, 6, 7, 8, 2 of the 8 they caught, right, are tagged. So they can estimate, well, if 2 of 8 are tagged, then, well, how do they estimate the population from that? Does it? They're going to use a proportion, exactly. So let's try and set it up. I'm just trying to get you a visual of what's going on, all right? Like how this is going to work. All right, so let's start out with the first number we have in here, which is 48 trout, right? Let's let X be let's let P be the population. So P is equal to the population of trout in the lake. That's what we want, isn't it? We want the total population. We want to estimate it. So they catch 48 trout, right, and tag them. That means 48 out of the total population are now tagged, right? I can write that down as a proportion. I can write 48 tagged, right? Tagged out of the total population, P. We know that for sure, right? We know there are 48 tagged trout out of the total population. Then they come back and they catch 300 of them, right? 300 of them. And 9 of them are tagged. So what we have now is that 9 are tagged out of the 300 caught. Is this making sense? To estimate the population of the lake, we can say that these should be approximately the same proportions. We had 48 out of the population were tagged. If we catch 300 of them and 9 of them are tagged, then that should give us, these proportions should be close to one another. It's not exact. That's why we're estimating. So if you set this up as an equation, do you see we have P here? We're solving for P. So we didn't do this in class. I always did it where I put what I was solving for on top, didn't I? But I wanted to show you one with P on the bottom, or with the variable on the bottom, because in your homework there are some problems where they have proportions set up that way. So just how do we do it? We can do like a cross multiply. Yep, you can do 300 times 48, and then you do P times 9. And what you would get is 48 times 300, which is 14,440. Oh no, 400. 14,400 equals, and then 9 times P. So when you multiply 9 times P, you get 9P. And then divide both sides by 9. 1,600. So we can estimate the population of trout in this lake to be 1,600 trout. Estimate. Okay, so that problem's a little different than the other problems because it's not an exact proportion, it's an estimate. All right, it's 12:08. Why don't we take our break? Y'all okay to take the break now? And then we'll come back and we're going to start conversions. Ten minutes, 12:18, we'll be back. And what number was that, sir? It was number 25 that you asked about?
25.
Let me look at it real quick.
It's a proportion, I thought when you did there now, but it has a percent. Yeah.
Oh, 18 is enough. Oh, yeah, it's not numbered.